Use your browser to access the unit at the IP address you've selected. Here's an image of the FreeWire unit. Here is a live webcam of units at the Amona office in our server farm for your access by subscription. Click in your browser and select from the menu of hardware modules, which are placed in the slots of the unit in any position you wish. Easily click to connect the terminals with connections, which are real electrical connections made up in the unit. In real time, adjust the amplitudes and gains and modes of the different modules remotely. These are all real modifications on the hardware itself. The function generator has several different signals to choose from. In fact, there are 19 independent hardware modules that you can choose from, as you can see in the menu, allowing you to make a virtually unlimited selection of different telecommunications experiments. Here we select and add a hardware modules, so we can just simply add two signals together. Viewing it using the digital 4-channel scope, fully featured scope. Of course, you can take screenshots, take measurements with cursors, adjust division, time base. This is not simulation. These are real-time signals coming to you from the hardware wherever it's placed in the world. In this case, the units are placed in Australia and the latency is completely minimal. Here I'm just arbitrarily adding two different signals. Once you've made an experiment, you can save it or you can load ready-made experiments. Let's have a look at a very simple amplitude modulation experiment I created for this demonstration. I can vary the DC, which is added to the message being a 2 kHz sine wave, baseband message. By varying the DC, I vary the modulation index. Students have to take measurements of all these parameters using the cursors and using the oscilloscope. They can capture waveforms to put into their report. And down on channel D, you can see the recovered signal using a simple diode, but you can also see a 100 kHz carrier feed through. This is very instructive because it allows students to see that a diode recovery unit is not ideal. There's the 100 kHz component remaining in the recovered signal. So to take this experiment one step further, we introduce a higher order low-pass filter, in this case a tunable low-pass filter, 10th order, and we connect the output of the diode rectifier to the higher order filter and view the output. Now, looking in the frequency domain and the time domain, students can see that the carrier feed-through has been eliminated and the signal is accurately recovered. They can also adjust the width of the low-pass filter, etc., to explore, take measurements and understand the work. Then you can save your modified work to your own account, give it whatever name, create multiple versions, and so on. The unit multiplexes itself to all the different users that are using the system at that one time. The unit can handle easily over 30 students at once. Example is Bpsk modulation with noise, modulation and demodulation, single channel. Displayed, we have the original data, the Bpsk signal and the recovered data out of the tunable low-pass filter. Loading another experiment, sampling theory. Please note that these experiments are all being implemented on real hardware and you're controlling them remotely. Choosing a different experiment simply makes different connections amongst the available hardware modules. Bpsk is another very simple experiment just to show what's possible. Bpsk generation using the spectrum, we can explore frequency deviation, obviously changing the time base, and triggering allows us to look more closely at signals. Many students at the same time can share this one system.